In this lecture, we will be seeing some examples of phase 1 reactions such as oxidation, mainly carried out by the cytochrome P450 enzyme system. So the first example is like oxygen of exposed alkyl group. So you can see this alkyl group CH3 is oxidized. This CH3 is exposed because it's at the end, and this CH3 was oxidized. And the next is also the same. This is closed structure, not a ring structure but aliphatic structure. So this alkyl group is oxidized to form a hydroxyl group. So the next example is oxidation of alkenes and aromatic rings. So here in this example, this alkene is oxidized to form like this oxygen form two bonds with two carbons of the alkenes. Also in this example, this aromatic ring, also the side chain of the aromatic ring is oxidized here by this P450 enzyme system. The next example is oxidation of N-alkyl groups or demethylation, that means removal of the methyl group. So in this example you can see this methyl group is removed, so this nitrogen is reduced and this methyl group is oxidized. So in brief, this nitrogen group or this nitrogen moiety is reduced, and as a result of reduction the methyl group is removed, and this reaction is called demethylation. So oxidation mainly occurs at this methyl group. So we will be seeing some example like drugs undergoing dealkylation or deamination or S or O oxidations. So in this example, the drug imipramine mainly metabolized and converted to desimipramine. So in this reaction the dealkylation occurs. That means if you can see this nitrogen, here two alkyl groups are present, and this nitrogen is reduced because hydrogen is gained here, and oxygen like this methyl alkyl group or methyl group is oxidized, like the example that we have seen in the previous slide. So where the nitrogen or alkyl group is present in the nitrogen is substrate to reduction, and this CH3 alkyl group is substrate or subject to oxidation. So this dealkylation means this CH3 is removed, and subsequently further oxidation will remove this second alkyl group. Also in this example, the nicotine or cotinine. So the nicotine, if you can see this CH3 can be removed like this. If that is removed, that is dealkylation. So this nicotine can be converted into cotinine by oxidation at this position, but this is not dealkylation. Dealkylation will occur here subsequently. So this nicotine then is dealkylated. So this alkyl group is removed. So because this nitrogen is reduced and alkyl group is oxidized, so this nicotine is converted into non-nicotine. And also this cotinine can be dealkylated, so this CH3 can be removed. So this cotinine converted into norcotinine because this CH3 is removed. So this is the mainly example of oxidation and mainly reduction by this P450 enzyme system. And the other example is deamination. That means this amine group will be removed, like this amphetamine. If you can see, this NH2 group is removed to form this NH3. So as a result of oxidation at this position, like at this carbon is oxidized, you can see. So and this amino group is reduced in order to form this ammonia. So this amino group is removed, so this reaction is deamination. So the next example is N-oxidation. So the position of the oxidation will occur at the nitrogen. So the drug mephentermine is oxidized at this position, this nitrogen position, you can see. And the other oxidation examples are oxidation at O and S position and resulting in dealkylation. It's like the same of this N dealkylation, but the alkylation is here, position is different, like at the atom is different, the O atom, oxygen and sulfur atom. So in this codeine can be converted into morphine. Like if you can see this, if you can see this O position is oxidized, like this whole OCH3 position is replaced by this OH group, and as a result this CH3 group, removal of this CH3 group is dealkylation. So another example is S dealkylation. So in this position, sulfur group, you can see this reduction is occurred in this S position, and as a result this CH3 is removed, or the alkyl group is removed, so dealkylation occurs, and the drug 6-methyl mercaptopurine converted into 6-mercaptopurine. So these are mainly purine analogs used in anti-cancer drugs, and morphine codeine is like opioid painkillers. So the next example, we will be seeing more examples of oxidative metabolism done by this enzyme, this large liver enzyme Phr450. So this type of reaction is aromatic methyl oxidation. So from the name aromatic methyl, so this aromatic group, this, and there's a methyl group here, so this methyl group will be oxidized. So you can see this methyl group is oxidized because there's gain of oxygen or hydroxyl group. So in order to make it CH2OH, so this methyl group is oxidized, and it is like, if that is the substrate of this enzyme system, this tolbutamide is the drug and substrate for this CYP450 enzymes, and this is the metabolite, the drug metabolite after the enzymatic reaction done by this P450 enzyme. And the second type of reaction is this alkyl side chain oxidation. So the drug phenobarbital, you can see alkyl side chain. So if that is the aromatic ring, or that is the aliphatic ring, and this is the side chain, this alkyl side chain, and this side chain will be oxidized. So in this example, you can see here this carbon is oxidized. If the carbon of this aliphatic alkyl side chain is oxidized, so hydroxyl group or gain of oxygen is oxidized. So another example is ibuprofen is the same. Here you can see this is aromatic ring, but the alkyl side chain, this side chain here. So this ibuprofen can be like two position of the side chain can be oxidized. So one is this position, and the other one is like this carbon position. So two carbon position is like susceptible for this oxidation. So one is this carbon and the other one is this carbon. So in both of the carbons the addition of hydroxyl group is present, so that means oxidation occurred. Another example of this enzyme system is heterocyclic ring oxidation. So the drug is phenmetrazine, which consists an aromatic and an heterocyclic ring. So this heterocyclic ring is oxidized. So this carbon of the heterocyclic ring is oxidized with oxygen, you can see. So this example is heterocyclic ring oxidation. So the next example is dehydration. So in dehydration, water molecule will be removed. So in this example, the drug valproic acid, which is an anti-seizure drug. So in this example, this side chain, like if you can see, this 2 hydrogen is removed. This 2 hydrogen is removed and another oxygen is given by the iron of the P450 system. So the iron molecule mainly gives the oxygen, but this 2 hydrogen is removed. So you can see this hydrogen is present here, and this carbon is like formed a double bond with this carbon, but this 2 hydrogen is removed. So and this CH3 CH2 is here, and this carbon is formed a double bond here, and 2 hydrogens are removed by the system. So removal of hydrogen is also called oxidation, right? So by this way we can see this drug can be dehydrated or oxidized. As a result of oxidation, dehydration occurs. The oxygen molecule mainly was given by the other enzymes, the P450 enzyme system. So oxidation of alkenes. So the drug carbamazepine, you can see this aliphatic ring here. The alkene is oxidized to form 2. So the carbon here, 2 carbon form 2 bonds with this oxygen. So this is some examples of oxidation, and oxidation can result in different sorts of removal of different sorts of functional groups.